Welcome to the lecture 2 on solutions, 12th chemistry, chapter 2. This is the second lecture on the solutions. So let's move on. So what is volume percentage? The volume percent is the volume of the component per 100 parts by volume of the solution. So it is like volume to volume type measurement, or you can take it as a calculation. And volume percent is volume of the component divided by total volume of the solution multiplied by 100. So this is the basic idea. Next, so we have a question here. 100 ml of ethanol is dissolved in sufficient amount of water so that the resultant volume of the solution is 100 ml. Find the volume percent of ethanol in water. So the answer is 10 volume percent of ethanol in water. How do we do that? Is volume of ethanol is 10 ml here, and the volume of the solution finally it is made up to 100 ml. So the volume of ethanol divided by volume of the solution multiplied by 100. So it is 10 by 100 multiplied by 100. So it comes out to be 10%. So it's 10 volume percent. This is how we give the calculation. And solutions contained in liquids are commonly expressed in the volume percent. And here we have a general question which sometimes they ask in the examination. What's an antifreeze? So the antifreeze is a 35% volume per volume. Okay, a 35 volume percentage solution of ethylene glycol. It is used as an antifreeze. Okay, it's mixed with water and it's used as an antifreeze in cars for proper working of the engine during cold conditions or cold winter. The antifreeze ethylene glycol lowers the freezing point of water to minus 17.6 degrees centigrade, or otherwise minus 255.4 Kelvin. So once it reduces the freezing point, right? So the what is this reduction of the freezing point says that see, assume that we have the outer temperature is like minus 4 degrees centigrade. Even if it is minus 4 degrees centigrade, the water will not get freezed, okay, because the freezing point is being lowered. So that is the idea behind the antifreeze. So let's move ahead to the next slide. So we have 35 volume to volume of ethylene glycol. What does it mean? That I have written over here. So first thing is you have to take 35 ml of ethylene glycol and add sufficient amount of water to it, so that the resultant mixture would make up to 100 ml. This is the idea behind the volume percent. And please don't think, this is the idea caution I want to write. Please don't think that we had to add 65 ml of water to make it up to 100 ml, as these mixtures are non-ideal mixtures. The delta V mixing is non-zero. Okay, so these are not ideal mixtures for you. You don't think that you had to add 65 ml. In fact, in the case of ethylene glycol, because it forms hydrogen bonding, you may have to add more than that of 65 ml. That's the idea behind it. So that's why we don't know the amount of water, how much you had to add to make it to 100 ml. So we'll say that we'll add sufficient amount of water to make it up to 100 ml of solution. That's how you calculate the volume percent. So let's see the mass by volume percent. So that is the weight per volume, and it is the mass of the solute dissolved in 100 ml of solution. So mass by volume percent is mass of the solute divided by total volume of the solution multiplied by 100. So that's the next one. Let us see the next slide. So we have a question. 10 grams of sodium chloride NaCl is dissolved in 100 ml of solution. Find the concentration. So concentration they asked in mass to volume percent. So mass by volume percent is mass of the solute divided by total volume of the solution multiplied by 100. So it's 10 grams which is dissolved in 100 ml. So it is 10% mass by volume. So this unit is commonly used in medicines and pharmacy. This is the idea behind it. So let's go to the next slide. And the next slide is about the parts per million. So what is this parts per million? Parts per million is expressed in three different ways. One is weight ppm, volume ppm, weight to volume ppm. So when a solute, so when do we express the parts per million is this is the reason, this is the situation when do you express the parts per million. When a solute is present in trace level quantities or trace amounts, the concentration is parts per million. So when you have very small amount of solute present in the atmosphere or any solution you consider, that is expressed in parts per million. Generally the pollutants, they are expressed in parts per million. So the ppm is the abbreviation, and then ppm is the number of parts of the component divided by the total number of parts of all components of the solution multiplied by 10 power 6. It can be weight divided by the weight, or it can be volume per volume, or it can be weight to volume. So that is the idea. And gas is dissolved in water expressed in mg per kg inverse. So milligram per kg, that is weight ppm for you. So this is how. So suppose I have 5 milligrams of something is dissolved in 50 kg of something. So that works out with. So you got to multiply that into 10 power 6, and that's weight ppm for you. So the next one is the concentration of pollutants in water and atmosphere is often expressed in terms of microgram per liter. So that's so this is a weight to volume percent. So here something like let's take an example like uh, there is something like 5 microgram of some pollutant is dissolved in some like 1000 ml of water. If I have this situation, that is microgram per ml. If I see this kind of situation, that is weight to volume ppm. So this is how we express the concentrations. So let's move on to the next slide. So the mole fraction, it is the ratio of the number of moles of one component to the total number of moles of all the components present in the solution. And mole fraction of a component is number of moles of a component divided by total moles of all the components. So let's move on to the next one. So mole fraction of a solute is chi solute. This is chi. So it's written like this, like something like x you had to extend like this. So chi solute is number of moles of a solute divided by number of moles of solute plus solvent, number of moles of solvent, and chi solvent is number of moles of solvent divided by the total number of moles, that is chi's number of moles of solute plus number of moles of solvent. So let's move on to the next slide. For a binary solution A and B, the chi A is Na by Na plus Nb, and and chi B is Nb by Na plus Nb. And chi A plus chi B is always equal to 1. When you add up these two, always you get the sum of the mole fraction. The sum of the mole fractions is always unity for a given system. And the mole fraction is independent of temperature, and it's a dimensionless quantity. That is another important statement which you have to know. So let's move on to the next slide. For a system containing I components, then chi I is given by Ni divided by N1 plus N2 plus N3, so on up to Ni, where it's an I component system. So Ni divided by sigma Ni, this is how you can write. For any given solution, the sum of all mole fractions of all the components is unity. So that is what is being expressed. So if it is binary system, chi A plus chi B is equal to 1. If it is a multi-component system which is containing I components, then the sum of all individual mole fractions goes to 1. So let's move on to the next slide. So calculate the mole fraction of benzene in the solution containing 30% by mass in CCl4. For 100 grams of solution, mass of benzene is 30 grams. As benzene in CCl4 is 30%. Okay. So 30% by weight. They said the solution contains 30% by mass. So that means 30 grams of benzene is present in the CCl4. That means they have taken 30 grams of benzene. They added 70 grams of CCl4 to make it up to 100 grams. So that's what it means. So let's move on. So molar mass of benzene is this much, 78 gram per mole, and molar mass of CCl4, I just gave the calculations. You can follow this. So that is 154 gram per mole. And number of moles of C6H6 is 38 divided by 78. So that is 0.385. And number of moles of CCl4 is 0.70 divided by 154, 0.455. This is how you get the numbers. Now we need to calculate the mole fraction. That is, mole fraction is chi C6H6 is number of moles of C6H6 divided by the total number of moles. That is chi n number of moles of C6H6, that is benzene, and plus number of moles of CCl4. So the numbers are here. 0.385 divided by 0.385 corresponds to C6H6, number of moles of C6H6, and the second one 0.455 corresponds to number of moles of CCl4. And then when you work out, you get 0.458. That's the mole fraction of benzene, and it has no units. Please understand, it has no units. And now, how do we calculate the number of the mole fraction of the other component, that is the CCl4? So we know that the number of moles of the mole fraction of C6H6 plus the mole fraction of CCl4 is equal to 1. That is for a binary mixture. As I told you that chi A plus chi B goes to 1. So based on this idea, I'm going to calculate. So chi CCl4 is 1 minus chi C6H6, and that's chi CCl4 is 1 minus 0.458, 0.542. That's the answer. That's the answer for you. And that's the end of the problem. That's it for this video. And thank you all. Thanks for watching the video. And thank you all.